Thank you so much, Jessica, for the introduction. And this is actually the first job talk I have ever trying to conduct. So I'm really excited to share this with all of you. And feel free to have any question during my talk. And I'm always excited to take more questions for clarification. So as Jessica mentioned, this is a talk specifically for HCI, but my work is a blend. It's an interdisciplinary field of HCI, AI, and healthcare. So that's why I changed slightly today on the title to be a little bit more abstract, but later on I'll be very in-depth on the HCI project. So not going to introduce too much about myself, but I've kind of not only work in the academia space, but I'm also working this summer in Google Research, last summer in Mayo Clinic, and also sometimes in Scale AI. So that's how I'm kind of getting all this kind of sense of industry, academia, and healthcare to see how we can employ or deploy this research at scale in the actual real world scenarios. So I started my PhD 3 years ago, and I have conducted a lot of research. But today I'm only going to talk about a very important projects in AI for healthcare or HCI for healthcare field. So I first wanted to do more kind of analysis or interpretation on this very confusing title. A lot of my PhD committee members are super not happy about this title because they're thinking it's too abstract. And a lot of times there's not really like that agi. It's not like really objective, really subjective. But hopefully after my talk today, you will feel this title more convincing. So if I'm talking about the two most important keywords here, one is the objective versus subjective. How do I define that in this talk? So for objective, I mean more by automation, by computer. So sometimes I refer it as artificial intelligence, and there are some subfields like large language models or machine learning. So LLM and ML right now is kind of a subset of AI, but there are also some very interesting topics. And in my research, there's also a component of the software hardware combination. So there are wearable devices like Internet of Things, and I'm also going to cover that a little later. So for the subjective end, as you can imagine, subjective involves a lot of the human beings, a lot of this kind of various stakeholders in one key aspect. And there's also several kinds of evaluations. It's not like a simple exam tests, which have a standardized scores. Many of the evaluations in the research or in the actual HCI healthcare world are pretty subjective. You define a rubric by yourself. And also user experience is also pretty subjective. Different people have different viewpoints on a product or on a prototype. There's also the challenges in deployment, especially trying to generalize it from a very simple prototype to a very broad concept. As you can also see it here, there's also two very important keywords, approaches and medical world. How do I interpret this kind of approaches in my PhD dissertation or research? So the approaches here I specifically want to mention are human-computer interaction. It could be one kind of the study design or approach to understand how can we integrate AI large language model into this subjective medical world. And there's also like explainable and responsible AI, this reinforcement learning with human feedback to make sure this is more aligned, more safety. And there's also like fine tuning and make sure there's having this machine learning models at scale. For medical world, I conducted several scenarios. I conducted my research in several scenarios, including working with structured and unstructured data like electronic health records. You can imagine it doesn't contain only the numerical data. Sometimes it has clinical notes. It has something like the treatment plannings. It also have the patient-physician communication platform in Epic, which is one of the EHR company, which has the in-basket message communication. And there's also aspect like patient education. So just a really brief explanations, you can see how complex is this kind of research can going to be. And I'm excited to share one of the questions that I got in my first year of my PhD, which is really 3 years ago this time. One professor asked me when I just talk about my vision on what I want to do during my PhD. The professor is like, why you need large language model in your research? We are HCI department. We are HCI lab. Why we really need that kind of large language model components? What can large language model really do? So after, I will say 3 years, I finally come up with an answer to answer it from 5 dimensions. The first dimension is definitely in errors. Why we want to use large language models. Large language models are capable of a lot of things, like it can automate, it can help to make it at scale. But there are some concerns on if there's large language models can generate lots of errors. So that's shouldn't use large language model. Or large language model can identify some of the errors and can identify the errors in detail. So we should use large language models. There's also dimensions like efficacy, right? Large language model accelerates the clinical workflow, or the large language model can accelerate some of the fields, but it cannot apply to some specific domain, for example, prostate cancer. And when we talk about user-centered or human-centered standpoint, we can see the large language model can tailor their answer to meet your personalized need. It can be very informative from a patient-centered manner. But there are also kind of considerations like large language model can hallucinate. It can create the human-like responses, but unfortunately, they probably made up those facts. They are not fact-checked at all. There's dimensions in trust, which is large language model can really provide all the details, and it can be very reliable when it goes to reference some of the existing contents. For example, if we make it closed domain, we don't use large language model to search on a very broad kind of database or the whole internet. Let's just focus on some of the specific elements. There's also concerns like large language model cannot really afford liability. And the last part, like evaluation, there are concerns like whether we have the standardized or good evaluation for large language model, as it's just emerging 3 years ago. None of us have a very good rubric to understand how to design this kind of evaluation matrix for large language models. So this is the actual research that I'm always thinking. And 3 years ago, I encountered this question. And the very interesting thing is to find the sweet spot, right? You can see this is a little purple love shape. And I'm very exciting. I was like, oh, I kind of define the scopes, the tasks. But unfortunately, in UMD 40 years ago, almost 40 years ago, Professor Ben Shneiderman's book, Designing the User Interface, already discussed a similar trend on this topic. As you can see in this kind of one dimension edge to edge, you can see the book mentioned about from purely human control to this automated by computer. And Professor Snyderman also discussed about, where's the balance point to find within like, should we go completely by human control, manually do everything, or should we do a lot of things, a lot of tasks by automating by computers? So this really drives my research to think about what can I design, what kind of the tasks I can design to make sure it's in a really good balance point and it's also in a good scope. So this is the project I mainly want to discuss in depth today. And this is the internship project that I conducted last summer. It's preprint last September, still under review. And it's kind of discussing whether we can understand the large language models applications in healthcare, and we specifically find a field called prostate cancer. And I'm going to explain why we chose prostate cancer later. So here I wanted to provide a screenshot that I took a few months ago. When you go to Google search, when you're trying to type in something like prostate cancer, you can see this 3 top contents or web page are all sponsored, which means they're probably advertisements. Sometimes they're not fact-checked. Sometimes they're concerned on whether this treatment passed FDA approval. This would be a little dangerous to have this kind of contents because a lot of these patients, when they're having or when they're getting diagnosed with prostate cancer, they're kind of frustrated, they're kind of very frightened, and they're trying to figure out the answer online. And as you can see, this is very generalized. There's probably not fact check. And Dr. Google can provide some answers which are deviate by its algorithm. So what can a large language model do? So in this study, we designed actually 3 sub-studies to interpret this. First, we wanted to see a needs assessment survey. We're trying to understand from the current prostate cancer patients in Mayo Clinic how they interpret their patient education, how they start the progress, how they trying to investigate on the specific concept. And then the second study is a co-design study. Actually, I have a little animation for that. So patients, right? This is the only one stakeholders in the first study. And in the second study, we're trying to have multiple stakeholders. So including the AI practitioners who designed the algorithms for evaluation, these clinicians who can help with this prostate cancer diagnosis or treatments, and there's also patient advocates who already suffer from the prostate cancer, who went through all this kind of very painful process and wanted to provide their feedback on how to improve the patient education. So we're gathering the 3 types of the stakeholders into co-design a prototype, and we define it as MedEduChat. MedEduChat is an abbreviation of Medical Education Chatbot. And in the third study, actually, I don't think I update the slides here, but we get to 15 patients now for our pilot study to conduct some preliminary analysis on how their feedback on this large language model generated prostate cancer education chatbot. We also get 3 clinical professionals to evaluate these interactions. So before we designed this MedEduChat, we first identified there's a 5E model from the education, from a lot of education literatures. So the 5E stands for, you can see here, engage, explore, explain, elaborate, and evaluate. And then after we get this kind of 5E process, we kind of divided them into 3 stages so it can be tailored to the prostate cancer patients. So the first stage we're discussing is called health outcome explanation. After the prostate cancer patients receive their diagnosis, they will first seek this kind of clarifications on what is it, right? So we first trying to engage this kind of prostate cancer patients in their conversations. And then the second step, we're trying to explore. So going from this specific concepts or specific cases, we're trying to explore from multiple EHR data and also education needs. And then the third steps we're trying to do is to explain in details, in depth on this potential treatment options and also explaining their diagnosis. They can also try to see several explanations about the other disease. Then they're going to the second stage, which is to understand this kind of learning enhancements. They get some basic materials to start with, and then we're trying to elaborate. So the prostate cancer patients can go from the basic concepts and elaborate to see if there's any personalized stepwise education. And then the last stage, which is the patient education feedback, which we wanted to make sure all the stages can go sustainably. So you can see after they provide their feedback, which they provide some evaluation on their education experience, their kind of feedback can fine-tune for their future use. Some of the questions they already asked before, we don't need to ask them again, but we can kind of reinforce them to learn from the existing concepts. So going back to the first study, what the patients really need from the current education. The patient education is quite different from a lot of the education right now, as they're more specific and they also not require some kind of the curriculum. They have a lot of questions by their heart. They're kind of driven or motivated by their own situation. So Mayo Clinic already have this kind of e-learning module. And e-learning module is kind of like Coursera or some online studies. So it starts with some questions and it also has some videos, some of the images or audio files. So here you can see from 5 different kind of evaluation matrix, we ask whether the existing e-learning module really helped the prostate cancer patients to learn. So you can see 80% of these participants think they helped me better understand my prostate cancer diagnosis, but there's also 20% feeling neutral or, they're just not sure. And there's also these participants who feel like it's not really prepared them to discuss about the prostate cancer diagnosis with the team. And we figured out it's probably because most of the e-learning module are pretty generalized. It's not specific to the case. And about the lens, most of the people think it's about the right lens, but there's also 10% think it's too short or too long. And we also discuss about whether this course contains enough details or enough information. And actually really good, the e-learning module performance, because 93% of the participants recommend this product or this kind of module to other patients. So starting from these results, we're kind of trying to reflect on what MedEduChat features can be designed. As I mentioned, we get 3 kind of stakeholders engaged in designing this prototype. So in the second co-design study, we first provided them several kind of like a flashcards for them to co-design this process. So we summarized these features into 3 main notable features. One is the closed domain. So as you can see, the MedEduChat first started with some welcoming sentences. Later on, we're going to show a demo video, but it will ask for the patient ID so we can connect them with the EHR. So in the closed domain, it first identified their ID. This is a hypothetical case. And and the MedEduChat is going to tell the patients on the specific diagnosis, what exactly has happened, what kind of date it is, and then the treatment plan. And then later on, they're discussing about the type of the radiation therapy started from when, ended on when, and it consisted of how many sessions with how many doses. As you can imagine, this kind of closed domain connect with the specific case. So when this patient trying to interact with the chatbot, they really get this kind of closed domain information. So they're not like interested in other date or other doses or other treatment plans. This is a patient case with an existing treatment plan. And then there's also like semi-structured. For example, they want to elaborate. Like if you refer back to the 5E model, there's after explanations, there's elaboration. Elaborate from the existing contents, what kind of the questions they're wondering. For example, here are several questions like what is prostate cancer? What are the prostate cancer symptoms? What are the risk factors associated with developing prostate cancer? And here you can see the gray fonts, which represents the patient's added information. So after they started from these basic questions, they can add their explanation. So we call this like a semi-structured or semi-guided, which stands for it's not really like they write all the prompts by themselves, but we're trying to guide them to ask the right question. And that goes back to my original question for myself, right? Why you choose prostate cancer as a specific patient population? The first thing is prostate cancer is not a really dangerous kind of disease. It typically takes longer time to do the treatment process. And the patients have a lot of time to reflect after the diagnosis before they decide on the treatment. So that's why we choose prostate cancer as this kind of main populations in our study. So in this semi-structured, I'm going to show a demo video later on. You can see how the people can add more information from the existing prompts. So they can ask better questions from it. And then the third kind of features is about the patient-centered. So some of the patients, they don't have very high health literacy. So they're complaining about the materials are so hard, they prefer to have an easier version or lower health literacy level. So instead of asking the MedEduChat to providing this, we provided some of the settings to adjust the MedEduChat. They can change the literacy level from different grades, right? 5, 7, college, or professionals. They can also divide the long context into different steps. So it could be in a better kind of shapes when explaining about several concepts. It can also specify the source of evidence to include the external websites or materials. So MedEduChat currently, it's only for text-based communication. It doesn't have multi-modal approach, so it cannot produce like videos or images, but it can produce some hyperlinks. So that's how it says specify the source of evidence, probably can include from external websites or materials. So here I'm going to show a demo video. It doesn't have sound. So first, it gives us a prompt. And then after entering the participant ID, they have several questions like this, like guided them. And then, for example, they're asking, what is the prostate cancer and how is the seriousness? So the MedEduChat not only provides us some generalized feedback, it also provides very specific explanations, like what is your specific diagnosis? Why this cancer is, how dangerous it is. And it's also breaking down the specific lab results, for example, the Gleason score, the PSA level, which are the important tests for prostate cancer. And also after they're finishing all this, they're going to continue the conversation by asking about, would you like to know more about the specific explanations or do you want to know other stuff? So this patient chose to continue knowing about the PSA level. So when it asks about a specific lab tests, you can see how it kind of separates, it gives some matrix about how to interpret the PSA level. And also it talks about in your specific case, how this PSA level can be interpreted. And then later on, it still guided them to ask more questions, right? Would you like to know more about the Gleason score or anything else related to our prostate cancer? So you can see it always go back to the patient's specific case, so we can keep on explaining these items that they're wondering. So you can see sometimes it asks several questions, it provides several sub-questions. So it gives like a feedback on, what specific questions that they're looking for. And the question is how the Gleason score is determined. And then they can end the conversation. And later on, the large language model kind of remember this process. So after that, they could continue the conversation in another day. So this is like a little demo video of how it works. And they can start another topic after the first one. For example, they're wondering about the other treatment options. They're curious about the other treatment plans, and then they can consider switching if they're feeling uncomfortable or they have some negative reactions with their first treatment plan. So they can learn more about the other therapies. So this is a pretty good conversation example of how the patients actually interpret or interact with the MedEduChat. Cool. I think I'm not going to show all the details here. And I'm going to the pilot study. So what's the results look like? What's the study design? So as you can see, the patient participants, after they get some diagnosis, they first will fill out a pre-survey. So we have a 20 to 30 minutes interactions with the MedEduChat. And in the post-survey, we're trying to get the assessments from 3 dimensions. The first one is whether MedEduChat satisfy their education expectation and also their experience. And then the second one is about their engagement or their interaction. There's a patient engagement score. So that's how we evaluate the patient engagement. And there's also the chatbot evaluation from the clinicians. So the clinicians have some kind of feedback for the existing chatbot on their chat history on multiple dimensions. So I'm first going to share the clinician grading results. We have 6 metrics in this evaluation. It goes from the answer's correctness to patient question difficulty, and also how correct is the answer? How complete is the answer? And also whether the response is patient ready, so the response readiness to deliver it to the patients. Also the safety and harm component, as well as whether the response is centered to the specific patient itself. So as you can see, this answer's correctness is pretty high. It goes from 1 to 3. So 1 means incorrect or not satisfied. 3 means highly satisfied, most all correct. So for all our interactions from our 15 participants, this correctness is pretty high, which means when it connects to a closed source EHR domain, the correctness performance is pretty good. And later on about the difficulty, as you can see, most of them are neutral difficulty. Some patients can ask extremely hard questions, but most of the patients ask like average questions. One is super simple. And also about this answer's completeness, you can see most of the answers are complete. The large language model provides complete response, but there's also concerns. Some of the clinicians have concerns like it should direct to the clinical professionals for more explanations. So there are some concerns on the completeness. And we're still kind of trying to figure out, how to improve from providing complete answers, not only by large language models, but also satisfied by the clinical professionals. There's also doubts like whether the response is ready. We also see this kind of trend is pretty good. It's pretty high, but it's also have some concerns on there are some cases which need fact check by the clinical professionals because the MedEduChat currently can only handle the text information. So maybe there are some like lab tests or there's some imaging results that continually needing the medical professionals for interpretation before sending out to the patients. There are some concerns on safety and harm. And as I mentioned, this is kind of similar to the concerns with completeness because there are some scenarios where the answers should refer to medical professionals for future discussion or verification. And then we can see this patient-centered response. It's kind of pretty good, deviate to this kind of patient-centered, but there are also some cases where it provides very general response and not tailored to patient case. And our system is a RAG system. So we're kind of trained on the specific closed domain information, but we can see from the clinical gradings, the results are more positive than we think. So we're continuing trying to fine tune it. There are also some qualitative quotes that I really like to share. Actually, in the paper, we discussed it more in depth about what can this kind of qualitative feedback engage us to think further. So I picked several quotes, and it's very interesting to see how patients learn from this process, how patients feel about these interactions. So for example, one of the patients says, I know I cannot get a yes or no answer from this esoteric question. The patient, by the way, asked a very rare drug on treating the prostate cancer. But explains not only what the drug was, but also how it differed from what caused prostate cancer. So this quote is kind of very notable because lots of the clinicians have trouble when they're encountering patients' question on a new drug or rare drug. And large language model can interpret it by finding in the closed domain source and also provides very good response. And there's another patient provides another feedback on how MedEduChat can act like a gatekeeper for the questions. And it can help to ease the anxiety of waiting for answers, especially you can imagine the prostate cancer patients after they got their diagnosis. It typically takes them 2 to 3 weeks, depending on their stage, to continue with the clinicians. So it's good to connect or to have an interaction with the MedEduChat before meeting the doctors so they can solve most of the questions. And later on, they can refer some questions that large language model, or in our case, MedEduChat cannot answer really well. So it's really good that some of the questions are not even resolved yet. This patient really asked some interesting question like, does dairy products like milk cause prostate cancer? So you can see some of these questions are like a myth. There's not kind of, they don't root on the facts. So kind of having this conversation before this visits with the doctors could be very helpful. There are some cases where clinicians showed concerns, whether the closed domain data can guarantee the correctness. the clinical evaluations that I showed in the previous slide is only based on the patient information. But how about the patient information, like that electronic health record, is wrong? So it could be some causal relationship, right? Like it's kind of cannot guarantee 100% correctness. There could be some manual errors in this foundation information, and it could also be like confusing abbreviations in the clinical notes, or sometimes there are missing data. Some interesting thing about the EHA profile is that even the data comes in a day after, it's still considered as the real-time information. So there might be some missing data, like after their visits, it's not kind of populate the EHR profile after finishing it. And there's also a very interesting feedback from a patient. And I still remember, when I conduct this qualitative interview with this patient, how he replied. The nature of AI, in my experience, isn't a one-stop shop. It's beneficial to go through it once and then maybe a second time to get more comprehensive responses. The answers might not necessarily be better, but they could be different and provide a better description. So as we can kind of interpret, a lot of time, large language model is not a one-shot experience, right? You should have multi-turn conversations to provide more context, to provide more background, so the large language model can have a better performance. It's hard that you ask a question like prostate cancer and it gives you all this tailored response. It's kind of like a process. So a little feedback from our reviewers is to adding this real-time safety workflow program. I never think about it when I started this HCI research that we're going to create a framework or a guideline for the future large language model chatbots or agents in this specific field. So this reviewer asking us, whether our study could stand for like a paradigm for the future research to continuing this kind of the safety alignment check or fact check. So you can see that it goes from the simple user prompts, it goes to data extracting the back-end closed domain EHR, and it should go with some kind of pre-filtering layer which can trigger the escalation for safety check. Whether this question is askable, whether it's feasible to get some answers. And if it's not flagged, it can go to the MedEduChat for generating the results. And it should also get the post-generation check. So it should also be fact-checked by providing some kind of audit logging to evaluate the scores like toxicity, hallucination risks, privacy leaks. And we also advocate for the medical professional review for the expert oversights. So building this kind of the safety or real-time safety workflow, we hope to build a sustainable paradigm for the future large language model agents or chatbots in the healthcare domain. So that's how we talk about it, like defining the borderline, right? Everyone have this kind of different questions that are not solvable, but I make this really cute animation to show, how can we match a lot of this kind of patient's feedback into drawing this borderline. Awesome. So this research is with many Mayo Clinic clinicians and also several academia people to help. So I'm very grateful for them to support this project. It's not the end. I'm still having some kind of information to reflect. So this is like last year's project, right? This year's project is still kind of under publication approval, so I cannot share too much information about my research at Google Research. But it's quite fun that we're asking a second question. How do people use this kind of chatbots to seek personalized guidance for complex health questions? And I think today there will be a blog talking about it from Google Research to talk about, why some of this chatbot could work well and what's not. And as I pointed out here, there's sometimes the personalized guidance have to be super relevant to the user. And also for complex health questions, it's very hard to answer in a simple sentence or paragraph. Sometimes it needs multi-turn or multiple rounds for explanations. And because it's a personalized guidance, so sometimes it's beyond basic facts. It's not like from a static book, I can find the results. I have to tailor this kind of facts to the specific case. So in my 2024 CSCW paper, I discussed about this kind of clinical patient relationship. How can we ensure that the medical professionals, in this case, the experts and patients, can have a very good communication? So I built this kind of framework from Lucy 2018's talk about the clinical problem solving maturation diagram. So you can imagine the experts starting from very low gathering of the patient data, but very high diagnostic accuracy because of their years of experience. And for patients, it could be novice or non-expert populations. They have a lot of data about themselves. They know about their symptoms, they know about their painful experience, but they may know nothing about this specific disease. So how can we find the sweet spot to make sure they're understanding each other and also having this good communication? So here is what we're advocating for, a hierarchy of clinical patient relationship. Instead of finding the sweet spot here, right, the data gathered versus the accuracy of the diagnostic, which we kind of thinking about it as breadth and depth, how about we can improving it to a better place with AI? Moving with this kind of AI, the patients could be semi-experts. They can learn more about the disease through this kind of personalized chatbot exploration. And for clinicians, actually, after the MedEduChat interactions, they can also see a summary of what patients caring about, what extra information patients provide in these interactions. So instead of focusing on non-optimistic, not the best results, we're trying to make sure the breadth and depth of the information by both patients and clinicians could reach 100%. So this is kind of our hope of the future clinician-patient communication or patient education in the previous project. This is the actual figure in the plot, but I think that one is easier to explain, how different parties kind of grow their knowledge level from different directions. So going back to my 4 years of PhD, I'm always thinking about it like an iceberg. The first year for HCI students, it's important to identify the gaps between what human can do, right? If you still remember Professor Ben Snyderman's one direction about manual or completely auto control, there is some kinds of gaps that human and computer can collaborate or can interact to improve the outcome. But after my first year, I'm kind of having a very bad situation because I cannot identify it super well. So the second year, I kind of looking more on something below this iceberg, right? There is something secrets behind it. So I'm trying to bridging the gaps between the human-computer interaction, because after you identify the gaps, it's not necessarily means that HCI or human plus computer could have a better results. So it's appearing that HCI is not necessary or not simply mean by human plus computer in doing a task. So right now, to future years, I'm looking at this kind of HCI problems like a bigger iceberg. Like I'm trying to overclaim that I'm already see something behind or below it. I'm envisioning HCI means the skills with multiple humans and combining their intelligence for greater response or outcomes. So it could be by multiple stakeholders, by multiple different large language models to deliver their tasks in a better way. So why? It's about like diverse human stakeholders and different models can produce superior results. So what's the future years, right? 5 to 10 years later, what can we envision in HCI with large language model? Large language model is only 3 year old, right? It's kind of not a really mature product, but we're seeing this huge potential and capabilities in deploying it in a specific field. And in my case, it's healthcare. We can see how this diverse human stakeholders with their well-defined tasks can advance the computer system drives exponential results. And this is how human plus human plus human with different kind of the computers plus kind of multiply together. So this is a really interesting topics that I'm eager to explore in the future stage. So what's kind of the immediate next step? I'm identifying two challenges, and I'm also encouraging people in UMD can also investigating on it. I know a few UMD HCI researchers, and I think they are also meeting the same problems and trying to address these challenges. The first is large language model is capable of a lot of things, but it's unclear about the capability border and also the threshold. So we have to identify what large language model can and cannot do in a specific medical setting. For example, it cannot replace clinicians on making decision. It can be a decision support tool or like a supporting role in this decision-making process. So there are some gray area, right? FDA has some new guidelines on guiding the large language model chatbots development in the medical field. There are some gray area that people can explore, but it could also have a huge potential risks or liabilities when conducting this kind of the prototype or product development. And in MIT, I'm part of the healthy machine learning group, and the group is figuring out a lot of the bias, fairness, and errors problem. The large language model can be tailored to the specific patient case. However, how about the patient is minority? How about there's very lack of the patient sample in the existing training data? It could also be a very big issue to encounter with the bias. And the second challenge is about the automation. Can we use large language model as a judge? In 2 years ago, if you asked me about this question, I would say this is a very, very dangerous thing to do. But right now, as there are more large language models, synthetic data, or more kind of data involved, large language model as a judge could be, in some sense, feasible in well-scoped tasks. But again, there's no reliable guidelines now in the evaluation for this large language model generated contents. So there could be some specific domains, unique requirements that it should adapt to. So the evaluation is not like one size fits all. It has to be very specific and tailored to the domain. So in the end, I want to be thankful for a lot of the organizations that I collaborated with. They really kind to share the data or share the funding for my research. And also these are all these amazing collaborators that I have worked with. And this talk would be impossible without them. So I think I still have around 15 minutes, so I can answer all kinds of the questions, and really grateful for this opportunity to talk.